Hey all, so we're going to actually finish up our Calculus 1 materials by actually jumping all the way ahead to chapter 9. So please notice that. We're going to do two sections from there. Chapters 7 and 8 are going to be covered in Calculus 2 materials starting after Thanksgiving break. But we do want to jump around because you will see this on AP Calculus 1 exams, which is what's going to constitute your midterm test in this class. So we're going to start by talking about slope fields. And so a slope field is, we can see some pictures going in here, and I will also be asking you to draw them yourself. So they look like this. Again, this should feel relatively familiar from previous classes. And the idea of a slope field is that it's a way to visualize a function when we only know about its derivative. So you'll see this when you have what's called a differential equation right here. And so on the axes provided, sketch a slope field for the differential equation dy dx is equal to 2 minus y over x. And so we don't know what the original function is, and it's going to be a little bit tricky because it's got two variables, so we know it would be an implicit function. But what we want to do is at least give ourselves a little sketch about what the function might look like if it passed through various points. So at these points, you will then just plug in the function to the equation. So for example here, if I am looking at the point, let's start 1, 1. Let's just start right here. This is the point 1, 1, which means that when plugged into the equation, its slope would be 2 minus 1 over 1, which means that it has a slope of just 1 at that point. And this is the idea of a slope field, is that if the function passed through that point, it would have a slope, in this case, of 1. And so I can sketch a little bit of the function here, that if it went through that point, the function would look like that at that point. The next question becomes, okay, well, what if it didn't pass through 1, 1? What if it passed through 1, 2 directly above it? Well, that would be 2 minus 2 over 1. So this one would have a slope of 0 when you plug it into the differential. So if the function went through the point 1, 2, it would look like this. It would be completely flat. And actually it's going to be, that's true for all of the values of y equals 2. So you can sketch that in right away. So the idea here is that if y is equal to 2, then that numerator is going to equal 0. And so y is unknown, but we do know at least that, oh, well, at y equals 2, there is a critical point. Those sort of things can be really helpful. If we sketch in the remaining parts here, we can then say, well, here m would equal negative 1, m equals negative 1/2, m equals positive 1/2, m equals positive 1/3, and m equals negative 1/3. So if I sketch in all of those, we have, if the function went through that point, it would look like this, a little bit flatter, positive down here, positive 1/2, or positive 1/3. So that would be the slope field. And if you wanted to neaten it up, you can erase your little notes, though I find that that's really helpful as you're working along. And we at least know a little bit about this function based on the positive below the line and then the negative slopes above that. What is a really common type question of slope fields for the AP is which of these is the slope field for, and then they give you an equation. So with all of these problems, I strongly recommend that you are going through them as a process of elimination. So the first thing that I'm going to do is I'm going to eliminate the ones that I say, okay, that doesn't make sense. And the first ones I'm going to eliminate, in this case, I'm going to go with A, because we can see negative slopes here, and these are both going to be positive always, and they're added together. So if I see negative slopes in any of these, I'm going to cross them out because there's no way this number is ever negative. And so for both A and C, we have negative sections. So I know that those can't be, right? We've got negative here and here. So process of elimination, I've now narrowed it down to B and D. And so then what I am looking for is a characteristic in one or the other that is going to help me. And so when I compare these two, they look pretty similar. The main difference that I see in D is that it's m is equal to 0 for if all x is equal to 0, right? This is the idea. However, if I look at my equation here, if x is equal to 0, y squared should still make it positive. So this should still be positive even if x is 0. So that's how I'm able to cancel out D as the thought, and therefore B must be the answer. And I'm not going to worry all that much. Now, one thing that's also helpful for slope fields that you don't often see, but I do want to cover it, is this idea that you can use it to sketch in a graph. So if you're given an initial condition, so let's say that the graph must go through the point 0, 1, which would be right here. You can use the points around it to sketch in the behavior. So going like this and then going like that, and that's one of the other uses of the slope field. Lastly, you might see basically the inverse of what we just did, which is which of these could be the solution to the slope field that's given. So instead of matching the slope field to the function, we're going to match the function to the field. So here we have our 5 options, and we have a slope field here that is always positive. And so I'm always going to start by crossing out the ones in this list that would have any negative values between 0 and 3. So if the slopes are always positive between 0 and 3, I can cancel out C and cosine because both of these have negative slopes between 0 and 3. They start out looking like that. Now for A, B, and E, those all have positive slopes going up like this, and then ln of x will go up like this. Now, what I notice about these two here is that they are getting steeper as x increases this direction. However, if I look at my graph here, and this is where the sketching idea comes in handy, you'll notice that if I follow this along, I'm getting less steep as I go. Which does that one look like of my options? It looks like E. And so that's why the sketching can be really helpful. And that is the one that I end up picking as my correct answer. Let me know if you have any questions about slope fields or anything else that we've been covering, and I'll talk to you later.